Quiz 1 solutions for, this is not Math 251, this is Math 211. A couple of word problems. This first one, we got a circular cake and we're cutting it up. We're making 4 cuts through the circle and trying to figure out the least and most amount of pieces of cake you could end up with. So a couple of different problem solving methods you could use, I suppose, but to me the easiest one would just be to draw a picture. So here, it's almost a circle. I'm going to pretend that's my cake right there. I'm going to cut this thing up. The first cut you make, it really doesn't matter where you put it. I mean, either way, you cut through the cake, you're going to end up with 2 slices. But then resulting cuts kind of depend on where you put them. So if I want to end up with the least amount of pieces, I don't want to make a cut that goes through this first cut, because if I cut this way, I'll end up all 4 pieces after just 2 cuts. But if I get a little bit clever and make a cut that does not intersect my first cut, now I only have 3 pieces. So if I'm trying to end up with the least amount total at the end, it would make sense to cut more like this, my first 2. And my third cut, kind of the same logic. I could have it go through here or somehow intersect these other cuts, but that's going to leave me with a lot of slices of cake. If I want to end up with the least, it makes sense to have this cut not intersect either of these 2 cuts. And then finally, that same logic for the last cut. I've done 3 so far. I need a 4th one. Maybe I'll throw it down here. Good enough. There's 4 cuts. It leaves me with 1, 2, 3, 4, 5 slices of cake. So, I don't know, the least number of pieces is 5. You could probably describe that a little bit better, follow our problem-solving methods a little bit better, but for the sake of brevity of this video, I'll leave it just like that. Most gets a little bit more interesting, at least I think it's more interesting. I'm going to start out with another cake. I'm going to try my best to draw a circle, although it's hard to do on a computer. Good enough. And I'm going to again make 4 cuts. However, now I'm going to do so a little bit differently. My first cut doesn't matter where I put it, right? Either way, no matter where I put it, I'm going to cut my cake into 2 different slices. My second cut, all I got to do is make sure that it intersects my first cut. So put it wherever the heck you want. There, fine. Now, after just 2 cuts, I have 4 slices of cake. As opposed to over here, after 2 cuts, I had 3 slices of cake. My third cut is again interesting. Essentially, what I want my cuts to do, if I want to end up with the most amount of pieces of cake, is to intersect as many of the prior cuts as possible. So instead of doing something like this, or even like this, where I go right through this point, I'm going to make my third cut go through 2 of these lines. So, I don't know, maybe something like that. And note that by doing that, I think I ended up with 7 slices of cake. 1, 2, 3, 4, 5, 6, and then 7 for this one in the middle, which is more than if you would put it anywhere else. And really, I guess what ends up happening here is kind of a guess and check and draw a picture thing. You're drawing different pictures, sort of guessing where the cut should go, and then seeing which of those cuts produce the most cake. So I have 7 slices so far, still 1 cut left to do. What I want to do is, again, intersect as many of these cuts as possible. So you can try looking at it a few different ways. The most amount of cuts you'll be able to intersect will be 3. And the reason why is I've only done 3 cuts already, and all of those are straight lines. So no matter which straight line I draw, I can only intersect each of those 3 straight lines once. So the most amount of intersections I can get is 3. So draw the line wherever you want. It doesn't matter where you draw it as long as it intersects 3 of those lines. So here we go. There's 1, 2, 3. Looks like I intersected 3 lines there. And that should result in the most amount of pieces of cake. Let's see how many we got. 1, 2, 3, 4, 5, 6. This tiny little piece in here. 7, 8, 9, 10, and 11. Another tiny one. Your picture will most likely look different than mine, but I think the most that you'll be able to end up with is the most number of pieces is 11. So really what I had in mind when I did this is 2 of the problem-solving methods we learned in the first chapter are guess and check and draw a picture. And I kind of thought that this would incorporate both of those problem-solving methods. Now that I have my answers, maybe I should go back and look through the problem, work out different problem-solving strategies, which is a good idea for you to do, because if you get it wrong, you can still get partial credit by doing that kind of stuff. But for the sake of this video, for these solutions, I'm going to leave it just like that. These are the two solutions, and I'll move on to the next problem. The next problem, this problem is very similar to one that we did in class. In class, it was called the hoops team, and we had forwards, guards, and centers, and they were 5, 6, and 7 feet tall respectively. And we were told the total height of the basketball team. It's the same idea here, except instead of the height of a basketball team being our constraint, it's the number of legs these living things have. So what's going on here is there are 7 people. There are some unknown number of rats, so maybe I'll say R rats, and there's some unknown number of spiders, maybe S spiders. And I know that when you add up these 3 things, 7 plus R plus S, there's supposed to be 100 living things. So 7 plus R plus S is equal to 100. Or if you want to make things a little bit more simple, we can just say R plus S. Maybe I should write this next to it or something. R plus S is equal to 93. It might be easier to just deal with the number of rats and spiders because the number of people is not unknown. I'm not saying I don't know how many people live with me, how many people, rats, and spiders are in this house. I said there's 7 people. It's not a variable here. So it might be easier to write your equation like this, but either one will suffice. So this first equation deals with how many of these things there are. And now I need an equation that deals with the total amount of legs these things have. So, well, let's see. Yeah, let's do it this way. People have 2 legs, right? So each of my 7 people have 2 legs. So if I'm counting up the total amount of legs, I'm getting 14 legs from these 7 people. Rats have 4 legs each. So if I'm counting up the total amount of legs that I get from rats, each rat has 4 legs, so it'll be R times 4. And if I'm counting up the total amount of legs I get from spiders, spiders have 8 legs. So the total amount of legs I get from spiders is 8 times however many spiders I have. And that is given to me in the problem to be 426. And similarly to what we did above, since my only unknowns are the rats and the spiders, it might be easier to rewrite my equation over here as 4R plus 8S is equal to, well, I got 14 legs from the people. Let's just subtract that from the total, and 426 minus 14 is 412. And the reason I subtracted that is, again, it's not an unknown amount of legs we're getting from people. I know I got 14 legs. So instead of thinking about the total amount of legs for things that live in this house, let's think about the total amount of legs for rats and spiders. I think it's easier to use these 2 equations right here. So I'm going to take these 2 equations, and what I have are 2 equations with 2 unknowns, 2 variables, and so I can solve this system of linear equations. I can say that let's see, I'm trying to figure out how many spiders there are. So I'm going to solve this first equation for R, say that R is equal to 93 minus S. And the reason I did that is because I can then take that and plug it into my second equation here. Instead of writing the letter R after the 4, I can write what I just figured out R was equal to, 93 minus S. And then I still have this plus 8S is equal to 412. And the advantage of this form of my second equation instead of this one is this only uses the letter S. The only variable in here is an S, which is the number of spiders, which is the answer to my question. So if I can solve this equation that only has one variable for S, I'd be done with the problem. And I can do that. I can take this 4 and distribute it through the parentheses. 4 times 93. Well, 4 times 90 is 360. And 4 times 3 is 12. So I guess I get 372 when I multiply 4 times 93. And when I multiply the 4 times the S, I get 4S. I'm kind of running short on room, so I'll jump back up here. I can combine like terms. I have -4 of these S's and I have 8 of these S's, so those net out to leaving me +4 of the S's. So what I can now do is subtract 372 from both sides of the equation. 412 minus 372 is equal to 40. And so to solve for s, I divide both sides of the equation by 4 and get that s equals 10. So there are 10 spiders. As I mentioned in class, algebra is probably the most powerful way to solve this question. There's lots of other ways you could do it, though. I bet what will end up happening is about half the class will do it algebraically like this, and the other half will do it as more of a guess and check method. How many spiders are there? I don't know. There's 100 total living things. 7 of them are people. Maybe 50 of them are spiders. Well, if 50 of them are spiders and 7 are people, I guess that would be 43 rats. Let's count up the legs. Oh man, I got way too many legs if you count up the legs that way. So I must have picked way too many spiders because spiders have lots of legs. So try a smaller amount of spiders. Maybe instead of 50, I try 20. Dang, still too much. All right, maybe I try 10. And then finally you'll end up at the right answer there. So either guess and check or algebra would be problem-solving methods that will work for this problem. I'm sure there's other ways you can do it as well. But I will end this video here and hope that this suffices for the solutions.